This presentation will give a brief description of the content of the wave chapter. First, we introduce the relevance of forecasting the sea state in order to ensure the protection of people and goods at sea and at the coastal zone. As we know, ocean waves are considered as main drivers for coastal erosion and several sectors of activities, such as ship navigation and operations at sea. Any change of wave climate can also influence ecosystems and biological cycle in coastal areas. Ocean waves can induce dramatic damages. It's then crucial to prepare and forecast as earlier as possible extreme wave events. We have seen in the past some really severe damages induced by the waves, for example, in the European coastal area. The waves play also a key role of controlling the momentum and heat fluxes from atmosphere to ocean in coupled system. And for this, it is really important to have the best description of sea state. One of the objectives of this chapter is also to help operational centers to implement in easy and efficient way a wave system, and then to respond to their needs in terms of safety of people and industrial activities in ocean and the coastal seas. The operational wave forecasting system provides skilled mean wave parameters such as significant wave height, mean wave period, and dominant wave direction on total sea, and also can provide detailed view on the sea state represented by directional wave spectrum, which shows wind sea and swell dominant wave partitions as shown here on the top on the right. We will give the state in this chapter, we will give the state of the art on wave modeling and recent advances in and development in terms of wave physics used in operational models. This will discuss the physics used in the wind wave growth, the swell and wave breaking dissipations, and nonlinear interaction source terms. The wave model is forced by several inputs, and the most important one is the wind forcing. The second important input is the bathymetry, which is really relevant in shallow water. And we can add also another important relevant related to the surface current. And then the wave model can include wave current interactions in the system. We will give a description of wave parameters needed for warning bulletins and several user applications. These wave parameters are derived from the wave spectrum, and we will also give indication on the output availability in the analysis or in the forecast period. Another important point in this chapter is the validation strategies in order to evaluate the wave system. This is important in order to ensure the reliability of the wave products. In this case, in this frame, so we will use data from the buoys, from satellite, and this will be described in detail in the chapter. Another important section which is important in the chapter is the discussion on the data assimilation in wave models. So this is really important, and we will describe the assimilation techniques, whether are ensemble, variational, optimal interpolation, and also their impact on the wave forecasting for open ocean and the coastal areas. So talking about the data assimilation needs to introduce the available satellite wave observations such as altimeters and directional wave spectra from synthetic aperture radars. Altimeters are more common used, and we have actually more than 6 altimeters flying, given a significant wave height for operational application. In this section, we will also discuss the importance of sampling of data in the assimilation system and the efficiency in leading time in the forecast. The chapter includes also the relevance of using wave ensemble in terms of going forward for probabilistic approach in order to improve sea state predictability and also managing the risks. This can help the forecasters to consider the best options in their scenarios. The way forward is to consider the ensemble with perturbation of both wind forcing and wave physics. This leads to better characterize and forecast the uncertainties on wave prediction. Finally, the chapter will give some showcases of operational wave systems implemented for different applications and ocean regions. Here we show an example of significant wave height provided by operational wave system during cyclonic season in the Indian Ocean. More details of sections of the chapters will be given in the presentation during the ETOOFS workshop. I look forward then to discuss with you on waves application, and also I look forward to answer your questions. Thank you.